Hello, in this video I will explain about the design and implementation of the assignment with topic food delivery system. It has been maintained in a repository in GitHub. Following is the readme file which will come in handy in understanding few things about it. It requires Maven 3.6.3 and above. It is built using Java 17 and Spring Boot is the main framework. For local development, it makes use of Docker image for MySQL version 8.3.0. Following are the steps for running the application locally. The commands can be executed as is to run the application locally. Once it is up and running, the Swagger documentation can be checked at the following endpoints. It has the attached Postman collection as well. Also, the database schema is attached for every single table which is present as part of this application. For example, this is a collapsible block. If you click on this triangular arrow, you can see the schema for the address table. The RDBMS MySQL has been used for the database storage. Then we have the testing section, which contains the screenshots from some unit tests and the Postman screenshots as well. It contains a table and we have a description column and a screenshot column. In the description column, I have explained the description about the screenshot which is attached alongside it. So the first one shows the Jacopo test coverage report, how much of the code has been covered as part of the unit tests. The next one contains the coverage for the service package, like how much of the classes are covered and the coverage as part of the unit tests. Then the test cases folder structure, what all classes are present in the test cases folder. Then some sample unit test cases are attached over here, and then next is the description of the step, like admin registration successful, how the admin is registered in the system and the response back for the admin. So from here onwards you will see the description, like what action has been performed and what has been the output from the Postman point of view. Now moving on from here to the code base which is present in IntelliJ, we can understand how the code has been organized. So food delivery system is the code base. If I expand it, you will see we have the readme file which we have seen as part of the GitHub. Then we have the pom.xml which shows all the dependencies which has been used as part of the development of this project. Then the Postman collection has been attached over here, and in the source folder we have two folders, main and test. Test will contains all the test cases for the project, and the main will hold Java and the resources. The application.properties file contains all the configurations about the application, for example like database configuration, port number on which the application is running, etc., etc. In the Java folder, we have a food delivery system application which will act as the running point for the application. Then we have controller package where all the endpoints will be resting. So for example, in the auth control, if you see, the endpoint is this class is a controller where the endpoints are starting with auth, followed up with respective endpoints, for example post, auth register customer, auth register restaurant, auth login. These all are post endpoints. The rest of the annotations like @operation, API responses, content, schema, these are used for generating the Swagger documentation for the endpoint. In this case, the register restaurant endpoint will consume a restaurant DTO, which will be validated using the valid annotation. If I open the restaurant DTO, so basically any annotation like not blank, these will be used for validating the input, and the schema annotation again will be used for Swagger documentation. The endpoint will return a response with the restaurant DTO only. Now, for example, for the registering the customer, it will have input as customer DTO and will return a response of customer DTO only. When we go inside the register customer method, you can see we are converting the customer DTO using a converter to customer object. This customer is nothing but a database representation on the customer table, and one reference or one object will refer to a row in the customer table. We are encoding the password which has been provided by the customer, since we cannot store sensitive data like password as a plain text into the database. And once we have encoded it, it will be saved into the database, and again it will be converted back to the DTO object using the converter itself. So controller will host all the endpoints. Then we have service package which will hold the business logic. Utils will mostly contain the constants and the converters. The model package will hold all the entities which are representation of database objects or the database tables. For example, the customer in this case, it has first name, last name, email, mobile number, a relation with other tables and their mappings. Then we have some exceptions which can be thrown by the application, some enums, so that it will help us in validations and using them across the application. Then we have security and config folder, which are quite important. So first we have open API config. So any class annotated with @configuration simply makes it a configuration class. As part of this documentation, this can be understood that this class makes sure Swagger documentation can be used to provide authentication when making calls to the listed endpoints. Then we have security config. So again, since this is a configuration class, it has already been annotated with @configuration, and we have been using password encoder, which is of type bcrypt password encoder. Then we have authentication manager. So any kind of authentication that can be performed uses first the password encoder that we have defined above. And in the security filter chain, so for any HTTP request, it needs to be authorized first. So basically, for any endpoint which begins with auth is permitted to everyone. That is because it contains either the registration endpoint or the login endpoint. Then we have Swagger resources endpoints, so that we can go through the Swagger documentation. Then we have, for example, user, customers, restaurants, menu, admin. All these endpoints are secured and can be accessed based on the role. For example, the user customers can be accessed only by either customer or admin. The user's delivery endpoint can be accessed only by delivery personnel and admin. And any endpoint that begins with admin can only be accessed by admin. So role-based access control has been implemented in the application, and any other endpoint requires authentication, which there aren't any in the application. For If any request fails because of authentication or authorization, then we have a JWT authentication entry point. This class makes sure that any kind of authentication failure or authorization failure simply returns with unauthorized error. Then we have JWT request filter. What this filter does is, it will be invoked once for every request. Any request that begins with auth will simply be skipped and will not require any kind of authentication or authorization, since this contains registration and login endpoints only. For any other request, we will use the authorization header, we will use the token, we will extract the username, check if the token is blacklisted or not, that has been user has been logged out and still using the token to access the application. If if the token is not blacklisted, then the username will be used and we will try to find the security context. If not present, we will simply load the user from the database, validate the token. If the token is valid, then the context will be set and we will proceed ahead. Otherwise, 401 unauthorized error will be thrown back to the user. Now, this in JWT util we have a validate token method. Here we are extracting the username, checking if the token is expired or not, and for generating the token as well, we are using this class only. For generate token method, we are preparing some claims which contains the rules and the ID, for example, like owner ID, customer ID, delivery personal ID, and based on that we will create the token with the timestamp with issued at and the expiration time, and we will use the secret key, which is a base64 encoded of RSA key, and that will be used to sign the token using the HS256 algorithm, and the token will be generated and returned back to the user. So that is pretty much of the very few basics of the application, how the things are implemented, how it is designed. Yeah, thank you very much.